When dealing with multi-step variable equations, you may have been told, oh, just do reverse PEMDAS. In reality, you shouldn't be doing reverse PEMDAS. You should be thinking about all the layers and all the steps applied to x, and then evaluating what you should do next, not just following an acronym. For example, say we have 3 times x plus 2 equals 18. So the way that you want to look at this is that instead of reverse PEMDAS, we want to look at how the layers work. So was 3 multiplied times x and this thing first, or was this done first? Well, we want to look at the shell first. It's packaged in a way that the two shells go around x plus 2, and then the 3 was multiplied onto it. Because the 3 is multiplied to this thing as a whole, it's not just the x. So you want to look at what was done first to the x, and then what was done after, and then how we want to do our order is the reverse of that. So as you can see, when we look at this, we have x, and then it was added to 2. So this was done first, because as you can see, we have x plus 2, and then it was packaged, and then we multiplied the 3 onto that. So we want to do the reverse of that. So we make note that this part was part 1, and then this part was part 2. So we're going to go in the opposite order of that, because that's how we should do it. So let's get rid of this. So first we're going to divide out the 3, because that was the most recent thing done. So we're going to divide out 3 on both sides, because this is multiplication. So we want to do the opposite operation, which is division. So we're going to divide out of 3. And when we get that, we get x plus 2 is equal to 18 divided by 3, which is 6. Now, it's as simple as the one before. The parentheses doesn't really matter at this point, but I left it in there just so we can see the same structure. So you have addition here, we want to isolate the x, so we're going to get rid of 2 on this side and then get rid of 2 on that side. So now we have x is equal to 4. We got rid of that because positive 2, negative 2 cancel out. So let's look at another problem. X minus 4 divided by 6 is equal to 5. So how do we figure out what was done to this equation first? Because the way we want to look at it is the layers. How was each step done to x? In what order? So let's look at the numbers. Let's look at the 6 first. Was it applied to 6? Well, no, because if this 6 was applied to the x first, then it would be only under the x, because say for example we started with x and we divided by 6. Then it would only apply to the x because the 4 wasn't there yet. But since it applies to the whole thing, we can conclude that the 4 was also there before the 6 was added in to the equation. Because, as I said before, if the x was only there, then it would just be x minus 6 and then we add on the 4. But clearly here, 6 is applied to x minus 4. So we should look at this being, the 4 being here first. So let's mark this as step 1 and step 2. And as I said before, when we are trying to undo all these layers, we have to go in the opposite direction when we want to isolate x. So because this was done last, we're going to start with this first. So, actually let's leave it there. Let's multiply this by 6 over 1, right? So this will cancel out. We get 1, we get 6 over 6, so that gives you 1. So this cancels out. But then we also have to multiply this by 6 over 1. So what we get next is x minus 4 is equal to 5 times 6 over 1, which is just 30. And then it's as simple as what we did before. 4, we got a 4, x is equal to 34. And that's how we got our answer. So let's look at a new equation. 2 times x plus 7 minus 3 equals 15. So the easiest way to look at what was done to the x is to look at what is next to it. So let's ignore this because this is not what's next to it. What's next to it is either what's in the parentheses or what's next to it. So the first thing that was done was what's in the parentheses, because 2 is applied to the whole thing as a whole. And as I said before, remember, if it was just applied, if we just had the x, then it would just be applied to that, and then the 7 would be separate. But that's not the case. This 2, as you can see, is applied to this whole chunk here. So this was done first because it's in the parentheses. Usually what's done first is what's in the parentheses with the x. So that's 1, sorry. And then after, which is next? This multiplication or this subtraction? Well, this subtraction is done to this whole block. If it was just done to the x plus 7, then it would just be x plus 7 minus 3, and then multiplied by 2. But that's not the case. The 2 times 2 is only done to this part, which is the first part. This is the first part. And what's done to this is the 2. To reiterate what I just said, if that's too confusing, this 3 is applied to this whole thing. If I only wanted if I did this next after this first part that we identified, then it would just be x plus 7 minus 3. But that's not the case. It's being subtracted from this whole chunk. So that's how we know that this part is second, because this is only being applied to this. It's not being applied to x plus 7 minus 3. It's only being applied to what's in the parentheses. So this is the first step, we added, and then after we multiplied, and so this part is obviously the last part. So as I said before, we want to do the opposite direction. So let's rewrite this so it's neater. So we want to do what we did last, which is the 3. So we're going to add 3 to x plus 7, because this is 0, equals 18. We want to do what's second now, divide by 2. So this cancels out, becomes a 1, becomes x plus 7 equals 9. And then subtract out 7, we get x is equal to 2. Lastly, let's do a challenge problem. Here I have 4 minus 2 times 3x plus 1 equals 10. So now this one's a little more complicated because there's something attached to the x. So how we want to think about this is, what's closer, the 1 or the 3x? The 3x is closer. And how I want you to think about this is 3 is just being multiplied to x. It's not even counting the 1. But if we look at the 1, it's being added to 3x. So the 3 was already here. But in this one, the 1 didn't have to be there already. So we're going to look at this one as 1, step 1. And then this one as step 2. You want to always start from the parentheses and then work your way out. So there, I already explained, it's part 1 because this is only done to the x, and the 1 didn't have to be there, but this one's 2 because the 3 already had to be there for this to happen. And then step 3, what did we apply to the 3x and this whole thing next? Well, this, because this has to come after this whole chunk. Because it's not like 3x plus 1 and we have this 4 added on, but this is applied to this whole thing with the 2 already there. But the 2 is only applied to this part that we already identified, and the 4 didn't have to be there already, so it's 3. And then this part is the last part, so we're going to identify that as 4. So we have 4 minus 2, 3x plus 1 equals 10. So we're going to do this in the reverse order. Let's subtract out 4, because here there's an invisible plus because it's a positive number. So we're just going to subtract out 4 first. So now we have canceled out, negative 2, 3x plus 1 equals 10 minus 4, 6. Then we're going to do step 3. We're moving backwards. So this is a multiplication in invisible. So we're going to divide because that's the opposite operation. So let's move it up here. We're going to divide it by negative 2 because we want to also get rid of the negative. If we work with positives and with the x, it'll be more simple. So we have 1 times 3x plus 1 equals negative 3. Now we don't really need this 1 here because 1 times anything is itself, so we can just leave it as this. So next we want to evaluate this. The parentheses is the only thing left, so we can actually open this up and keep it like this. And then this is the next step, so we're going to just subtract out 1. 3x is equal to, because this cancels out, negative 3 minus negative 1 gets more negative, and then we're going to divide out the 3. X equals negative 4 thirds. And that's how you get that. To sum up, what you want to do is first identify the layers. What was done to x first, and then what was done after, and then what was done after that possibly if there was a third step. And always look at what was in the parentheses with the x first to determine what was done first to the x. And then after that, in isolating the x and figuring out what x is equal, you want to do the reverse order. So you uncover all the layers that was done to the x until you get down to the bare x and you figure out what it was equal to in the first place.